Consider the reaction between hydrogen bromide gas and hydrogen and bromine gases. In this example, we'll do a type of equilibrium calculation where we go from an initial set of conditions to equilibrium conditions using a K value. So for this question, imagine that you have initially an empty container. It's under vacuum. The concentration is 0 for everything inside that container. And then you introduce some HBr. We introduce enough HBr to bring the concentration in that container up to 0.100 molar. We then leave the container alone. We wait for the equilibrium reaction to occur. Some of the HBr breaks up into hydrogen and bromine gases, and an equilibrium establishes itself. If we give this enough time to reach equilibrium, we should find that the concentration of HBr is smaller than 0.1 molar, and the concentrations of H2 and Br2 are now greater than 0. So the way that we can calculate equilibrium concentrations is by using our K expression. The next thing we need to do is we need to plug in all of our known values. Initially, our concentration of HBr is 0.1 molar. And initially, concentrations for hydrogen and bromine are 0. Our concentration of HBr has to go down, and our concentrations of H2 and Br2 have to go up. And we have no information about our equilibrium, so we'll have to put some placeholders in. Now we can take this information and we can plug it into our equilibrium expression. We can simplify this a little bit. Now we could expand the bottom term, or we could recognize that X is going to be extremely small compared to the initial concentration of HBr. Our Kc value is tiny, 10 to the minus 18, which means that this reaction doesn't proceed very far to the right, to the product side. So we know that because our Kc is much, much smaller than our initial concentration, more than 1,000 times smaller, that we can basically ignore the change relative to our concentrations. So we can rewrite our expression like this. We can't get rid of the x's on the top because they're multiplied together. So when you multiply a very small number by a very small number, it has a very, very large effect. The number gets much, much smaller. But when you subtract or add a very, very, very small number, it doesn't change the initial number very much. So now we have an expression that we can work with. Now we just have to solve this expression for x. Now we have a value for x, 2.4 times 10 to the minus 10 molar. And now we can take this value and plug it back into the terms that we have for our equilibrium row. Right away we can say that the concentration of H2 and Br2 is just x. And the concentration of HBr is 0.1 minus 2x. And you can see that because the x term is so small, it actually has almost no effect on the initial concentration.